What's Owen on?
What's going on? What's going on?
Alrighty guys, today we're doing something different. Scotty's got a job in the mines, he's working away, he's not always in town, and Ben's got a gap from uni exams. So we're gonna do something that we don't necessarily need Scotty for, just to give you some content. Scotty's definitely not gone forever. We miss him already. Love you, Scotty. So I'm gonna run through some Technic stuff, directly related and vaguely related to some of the stuff we built while we were on the show. So, without further ado, let's jump into it. Obviously, we were on a show of national proportions, building Lego. So I was spending a lot of time practicing in the hotel. I would say we, but Scotty knows where he stood with his PlayStation. I found it really difficult to practice though. My attention span isn't great unless I've got an objective in mind. And it was really hard to practice on the show for what was coming up because you had no idea what was coming up. So you could practice building houses, but you may never need to build a house on the show. So one thing I kind of landed on really quickly, and the reason why our Technic improved so drastically throughout the show, is Technic is kind of applicable everywhere. So if you design a mechanism that, I don't know, like pushed and pulled, that could be applied to lots of different situations. You could have like a bull that runs out of a circus tent or whatever it may be. So I think developing the Technic components and different mechanisms was a good way to practice, and it also was compatible with lots of different builds. So the first thing I'm gonna do is I'm gonna build with a worm drive. We'll go through some of the worm drive stuff and we'll build something that oscillates this switch. So you get an on-off function from an external motor. So you turn one motor on and that motor actuates this switch. And that kind of is practical programming, I guess, in a sense. Instead of doing it in code, you're doing it in practical mechanisms, which I found quite cool. So I've got a motor. Doesn't really matter which motor, and I'm gonna turn that into a worm drive, which will drive a cam, which is a 4-bar linkage, onto the end of this switch, and that will oscillate the switch. So the typical worm drive components you need is a worm gear, and then this coggy piece. I don't know what it's called. There's some simple ways to make worm drives with only Technic pieces. I'm gonna use some Technic bricks just because it means that you can kind of index on the switch a bit better, and then it fits into Lego builds a lot better. But you can use these pieces here to make quite a quick and easy worm drive, just to get circular motion slowed down quite quickly. But all this does is it'll let us to reduce the speed of the motors very quickly without having to use lots and lots of these in a row. All right, let's build this thing. The basic geometry of a worm drive setup is if you've got sort of 3 Technic holes, the bottom hole is where this gear sits, and the top hole is what drives the worm drive. So we've just got to build a little box that keeps the Technic spacing correct so that we can have an axle coming in this way that drives that worm drive, and then the output will come off here. So the input comes in here, this spins really fast, and that then spins this piece really slowly. So I'm going to build a little box. Now using our stud mats, if you use 2 plates between bricks, like that, your holes still line up. So that keeps you in the sort of standard Technic numbers. And then by going that way, we can now get our hole facing the other direction. So we can start to have our worm drive in there, and then obviously the rest of it down below. I mean, this is kind of a roughy guidey, hopefully. It should be pretty universal. I think you'll be able to kind of figure it out. It doesn't have to be exactly these dimensions in the way of studying. You can use shorter pieces, longer pieces, but the rough gist of it is what we're after. Okay, so we've got our little worm drive here. Motors plug straight into that. We've got our 2 plates, and now we can go and build on top of that one there. So those are the 3 plates apart. So because we've done that right, this here will line up. Worm drive, driving our gear. So that you can see our worm drives driving that, and then we've got our output shaft here that's moving at a sort of reasonable pace. We now step this down. So what I'm going to do is I'm going to gear this down again one more time. I think the best way I've had it explained to me is if we get a bit of paper. If this is the start line, all right, this gear here and this gear here, they're driven by the same motor, right? So if we take this one through an entire revolution, where's something I can like mark a direction with? So this gear here, the wheel is up, it's at the start line. It goes through 1 rotation, and it gets to here. And this, it's turned once, right? So that's as far as that one got. This one here, this is gonna not work very well because now it's got a thing sticking out of it. For this one to go through one rotation, it only gets to there. So for this one to catch up with this one, it has to turn through like 4 rotations to get the same distance. So essentially, for every 1 turn this one does, this one has to do 4 to keep up with it. Or alternatively, if you're driving this one does a full revolution and this one will only do a quarter of a revolution. So it'll slow the speed down. So we're gonna put the little one on the drive shaft. So then we're gonna slow it down even more. This one's gonna run around once. This one's only a quarter turn. So as this one goes around 4 times, this one will only go around once and then we'll be going a lot slower. That's the bottom line. We're going for slower. So if we run that, you can see this one here is going about 4 times as fast as this one here. So we've got a worm drive, driving this one, which is then driving this one at the same speed as this one, and that one's then going the same, this one's now going 4 times as slow as that one there, and we've got this output here. Now, with that output, what we're gonna do is we're gonna put an arm on it like this. And if you watch this end of it, that arm moves in and out. We're going to use that in and out motion to actuate our switch. And that is the basis of part 1 of the switching direction changing machine. I'm going to have to stud this down and figure out the stud maths again to where this switch sits, but that's what we're going for. And you can see that our switch is turning. So I'm going to have to do some quick maths to figure out where exactly this is and how long this bit should be. But that is the gist of what we're doing. We're using one to switch the other. And then what we can do is we can plug a motor into this side and start doing all sorts of fancy things. We've got our switchy thing working. I'm just going to plug this switch into the same power. So that switch is now getting power. Now if I plug the lights into the same switch, as it switches, light on, light off, light on. There's a little bit of brick bending, but we'll allow that. Light off, light on. So that's the concept. This switch is obviously powered off the same power source as this motor. This motor, all it's doing is driving that switch. To change the speed of the flashing, you just speed up the gear ratio, so you could drive it straight off here. And then obviously it would cycle the switch faster and you'd be better off. From here, we use this output to do some other things. So there's a few different things you can do with this. The important thing to note here as well is the switch goes both ways. So if that's not a light and that's a motor, it actually reverses the direction. Come here, you. All right, so you can see that it reverses the direction as well. It'll spin one way, it'll stop, and it'll spin the other way.
Wow. Yeah.
Because it's swapping the direction of the switch. This is when I realized that now I can do some pretty clever stuff, because this motor can also run switches. So in our final build, I actually had kind of a daisy chain of switches that would switch switches and switch other switches to switch those switches back. And if you watch closely, they don't look at it at all, but the light kind of pulses inside our glowing energy. And that's, I think there was about 4 switches and 2 motors that would kind of actuate each other and a light at the same time. We're gonna build a rack and pinion. That's rack. And a pinion is just a little gear that runs along the rack. So we're going to use that to drive a forward and back motion. So the same deal with rack and pinion. Obviously, the bigger the rack you use, for every rotation, it's going to travel further, so the faster the motion will be. So we're going to use a really small one so that it travels at a sort of reasonable speed. All right, so that's the rack and pinion. And then you can see if I twist this end, we move in and out with our rack section. You can see how this kind of gets out of hand very quickly. It makes you look like a mad scientist. We plug that in there. Now if we turn our switch on, it goes, it stops, it goes, oops. Alright, we're gonna have to gear that down because it's obviously going too far. Right, we're geared down, we've got a rack and pinion. Which way is that going? The wrong way. Alright. So we're coming in, we're stopping, we're going back. So that's our forward and back. But it's not. So, this isn't perfectly repeatable, is something I realized. If we let this run, the time it spends going forward and the time it spends going backwards is not perfectly equal. So what you end up with is this whole arrangement starts to creep, and eventually it won't go all the way to each end. It'll start running past on certain sides. But there is a way to mitigate it. So the way to mitigate it is with hard stops and clutch gears, which we're gonna do now. So to get it to be perfectly repeatable every time, we're gonna put hard stops on the end so that it rams up against stops. And the other thing we're gonna do is use a clutch gear so that there's compliance in the gearbox. We can use these pretty blue ones that I'll never use for anything else, because what kind of color is that for Technic? What piece of machinery are you ever gonna build that's that color? Come on, Lego, give us like yellows and blacks and grays. We like those, we're happy with those. So a hard stop is just, a hard stop, I guess, is it's kind of a bit self-explanatory, but those who don't follow much engineering terminology, it's like a repeatable index position or something that just stops you over traveling or moving past something. So it's just something hard that you stop against. The other important step here is a clutch gear. Now, a clutch gear is like a normal gear. The reason they call it a clutch gear is that it's got a clutch in it. So if I put an axle through there, I can hold this gear still and move the axle. So it's got some sort of like friction connection inside the gear. So it does turn the gear, but when there's too much torque, it turns the axle freely. So what will happen now is we will drive, this will hit the hard stop, and it'll keep driving, but the rack and pinion won't move. We'll bang that in there. That just replaces our other gear in the gearbox. And now if we turn her on, provided I put that hard stop in the right spot, we have a perfectly repeatable left to right movement, or front to back. Now, we need to make switches trigger with this. The other trouble is, if we flick a switch in one direction, it's on. If we flick a switch in the other direction, it's still on. So we have to be able to hold the switches in a vertical position to stop them just going from on to on as this bumps them. This is like a proper mad scientist vibe again. We've slipped straight back into character. So now if I put an axle, ooh, that's not gonna work. So the hard stop's gotta hit it, but it's also gotta be able to catch it on the return journey. So to get there, we need a compliant switch. And a compliant switch is a flexi tube switch. So the reason I made this so long is because this is Lego Flex Tube. They use it, I use it on trains, for like hand railing. They use it all over the place. On sailboats, this is really not very safe. But if I put that in there, it's compliant, the switch can move past it, it can pause, and then it'll go back the other way. At the moment it's too long and it's kind of like flicking it back. That's not what we want. So we're gonna cut this down a little bit till it's the perfect dimension. So you are allowed to cut this stuff. This was the one piece of Lego that you are allowed to modify on the show, and also I believe in some Lego kits they actually get you to cut it, some of the older ones. So we're gonna cut this down just a bit and see what happens there, if that's enough. So if we're watching this light here now we're going back the other way and the light turns on again. Because obviously the switch is on in both directions. So now we have this problem to solve. This one was actually the easiest problem to solve, but it took me a little while to get there because I was so like focused, right? The way to solve it is we put another hard stop in. And we just restrict the physical movement of the switch so that it can't go past vertical in one direction. So now the light turns off and then turns around and then the light turns on. And that is essentially what ran the inside of the light up levels on the Strum King. The benefit of this, obviously, is then we could stack these switches. So there was 3 switches on the bottom. Obviously, I don't have any more switches. So then as it moves along, it'll turn the first switch on, turn the first level on. Then it will turn the second switch on, turn the second level on, turn the third switch on, and turn the third level on. The other benefit of having an actuator switch is you can now put a motor on here as well.
Yeah.
So on the top level, we had our drum kit that spun, and that was run off the top level switch. So this switch would also, it'd have lights for the levels, and then on top of that, it would have the motor cable to run the motor. And that is the logical progression of how we got to a light sequence that turns 3 switches on in series and then turns them all off. And if you listen to the episode, I think you can actually hear a dunk, dunk, dunk as it does that up and down inside the back of the build. And this was kind of like all hidden vertically in the back of the build. There's obviously lots of applications to this. You can use this not just in arcade builds, you could use it if you want people to, I don't know, dance with different people in a scene and you want them spinning around. Like once you've got this power output, you can have anything coming off this. So you can sequence like kind of a build of movement, and then the movement can all shut off in sequence as well. And to my knowledge, I mean, it ran while we were filming and it ran most of the day, so it seems to be a pretty robust system. There you go. That's how you get Lego power function actuating lights and functions in sequence. Ooh, there's definitely a cleaner way to do this. This could take a bit of refining to make it a bit of a cleaner system. But yeah, that's the principles behind it. There's a few logical steps there that we went through. But yeah, I was pretty happy with the end result. I think the key pieces if you're doing any Technic stuff is if you can get hold of the old Power Functions kit, they're really, really good. If you're more into the coding side of it, definitely the better way to go is the powered up stuff. You can code it, you can do it all on your phone and run it all that way. I kind of like it when it's a bit more practical and it's just on and off and you can see the kind of mechanics of what's going on. So to do it this way, the Power Functions kits, I think they used to be about $100. They're probably up a little bit more than that now they're retired. They come with a battery box, they come with a small motor, they come with the clutch gears, they come with a switch, and they come with the lights. So with one of those, you can get most of this. You probably need a second, you probably need a second one of them to get an extra switch and an extra motor to then start actuating stuff off that, and that'll give you lights and stuff. But to be honest, I think just playing around with gears is a starting point. If you want movement in Lego models, the hardest thing is to get the speed of the model to change. So just playing around with how to make worm drives is a big kind of like step into mechanizing some of your Lego. Ah, where's Scotty? Scotty dog, new digits. He's probably not going to pick up.
G'day.
Hey Scotty, how you going?
Good man, yourself?
Good, you're going live to YouTube right now. Is there anything you want to tell your fans?
Oh, hello YouTube.
Good content. I love it. Just wanted to know, there was maybe some digs at you earlier on...
Yeah, no doubt.
on the amount of practice that you conducted while we were on the show. Did you want to defend yourself in any way about the level of commitment to practice you had?
Hey, practice makes progress.
Yep.
But some people don't need to practice because it just comes naturally.
Ah.
Unfortunately, it doesn't come naturally to me, but Assassin's Creed isn't going to finish itself.
You've done a terrible job of defending yourself, and you just implicated yourself further. Well done, Scotty. Thanks for watching, guys. Hopefully it's a little bit of a different pace for the most of our videos. Obviously, we had a little bit of a cameo from Scotty. He'll be back for the next one, no doubt. We're going to do some stuff. Hopefully in Minecraft, we're going to do some stuff. Hopefully in the new Lego store that's opened up near us. We want to do some pick-a-brick cup challenges, which is a cool idea we have. It's probably been done before, we haven't heard of it. We're going to go in, we're going to fill up a pick-a-brick cup, we're going to build some cool stuff out of that pick-a-brick cup, see what we can come up with. Yeah, we're really keen to see the new Lego store as well, share that with some of you guys that aren't here. Yeah, thanks for watching. Hopefully you had fun. Hopefully you learned some stuff today. It wasn't just all about Nubians. Yeah, we'll see you next time. In the meantime, make sure you brush your teeth. Make sure you only wear your undies once a day. Don't go through like a week in one pair of undies. Nobody wants that. You just don't be that guy. Come on, use deodorant, guys. That's it. Stay hygienic and look after your soft plastics.
1, 2, 3, 4.